Dive into the world of Bernoulli's theorem with this comprehensive question bank, designed to test your understanding of fluid dynamics and its real-world applications. From conceptual questions to application-based problems, this collection will challenge and enhance your knowledge. Dr. Santosh Kumar Singh. Bernoulli's theorem is a cornerstone in fluid dynamics, explaining the relationship between pressure, velocity, and height in fluid flow. Formulated by Daniel Bernoulli in 1738, it reveals how an increase in velocity results in a decrease in pressure or potential energy, a principle that underpins many engineering applications. Bernoulli's equation expresses the conservation of energy in fluid flow, highlighting the balance between pressure, kinetic energy, and potential energy per unit volume. This equation is crucial for analyzing fluid behavior in various scenarios, especially for incompressible, non-viscous fluids in steady flow. Bernoulli's theorem relies on several idealized assumptions, such as steady flow, incompressible fluid, non-viscous flow, and no energy losses. These assumptions simplify the application of Bernoulli's equation, though real-world scenarios often require adjustments for viscosity, compressibility, and turbulence. Bernoulli's theorem is fundamental in designing flow measurement devices, aircraft instrumentation, and specialized equipment. By understanding pressure differences and velocity changes, engineers can accurately measure fluid flow rates and enhance navigation and control in various systems. Bernoulli's principle is evident in everyday phenomena, such as the lift on airplane wings and the railway platform effect. These examples illustrate how changes in pressure and velocity can have significant impacts, from enabling flight to creating potential hazards in high-speed train travel. Test your conceptual understanding of Bernoulli's theorem with questions that explore its fundamental principles. From the equation's statement to its assumptions and the relationship between pressure and velocity, these questions will deepen your grasp of fluid dynamics. Explore real-world applications of Bernoulli's principle through questions about Venturimeters, roof dynamics in strong winds, and Bunsen burners. These scenarios demonstrate how Bernoulli's theorem is applied to solve practical problems in fluid measurement and behavior. Challenge your calculation skills with questions on pressure differences and output velocity using Bernoulli's equation. These exercises will help you apply theoretical knowledge to practical situations, enhancing your problem-solving abilities in fluid dynamics. Evaluate your understanding of Bernoulli's theorem with true/false questions that address its applicability to compressible fluids, the relationship between fluid velocity and pressure, and the constancy of energy per unit volume. These questions will clarify common misconceptions. Test your knowledge of Bernoulli's principle with multiple-choice questions that explore its validity in different fluid types and its role in generating lift on airplane wings. These questions will reinforce your understanding of the theorem's practical implications. Objective questions challenge your understanding of fluid measurement and airspeed using Bernoulli's principle. From Venturimeters to Pitot tubes, these questions highlight the theorem's application in determining flow rates and airspeed in various contexts. Delve into application-based questions that explore the relationship between fluid velocity and pressure, as well as non-contact forces. These questions will enhance your ability to apply Bernoulli's theorem to real-world scenarios, improving your analytical skills. Use the answer key to assess your understanding of Bernoulli's theorem after completing the questions. If you missed any, revisit the relevant sections to strengthen your grasp of fluid dynamics and its applications. In summary, Bernoulli's theorem establishes the relationship between pressure, velocity, and height in fluid flow, with wide applications in engineering devices and exam preparation. Mastering the questions in this bank will help you excel in fluid dynamics examinations and practical applications.